Susmitha, Assistant Professor, Department of Computer Science and Technology. Today we are going to discuss about the implementation levels of virtualization. Virtualization is a computer architecture technology by which multiple virtual machines are multiplexed in the same hardware machine. The purpose of a virtual machine is to enhance resource sharing by many users and improve computer performance in terms of resource utilization and application flexibility. Hardware resources, CPU, memory, input output devices, etc., or software resources, operating system, and software libraries can be virtualized in various functional layers. The idea is to separate the hardware from the software to yield better system efficiency. For example, computer users gained access to much enlarged memory space when the concept of virtual memory was introduced. Similarly, virtualization techniques can be applied to enhance the use of compute engines, networks, and storage. Before virtualization and after virtualization. Before, in traditional computers run with host operating system specially tailored for its hardware architecture. And after the virtualization, different user applications managed by their own operating systems, that means guest operating system, can run on the same hardware independent of the host operating system. This is often done by additional software called a virtualization layer. The virtualization layer is known as a hypervisor or virtual machine monitor. The VMs are shown in the upper boxes where application run with the own guest OS over the virtualized CPU, memory and input output resources. The main function of the software layer for virtualization is to virtualize the physical hardware of a host machine into virtual resources to be used by the virtual machine exclusively. The virtualization software creates the abstraction of VMS by interposing a virtualization layer at various levels of computer system. Common virtualization layers include the instruction set architecture level, hardware level, operating system level, library support level, and application level. So the architecture of a computer system before and after virtualization. So the traditional computer hardware, host operating system and applications. After the virtualizations, so the various applications simultaneously the application 1 and 2, the guest operating system, hardware, virtualization layer, that is the hypervisor or virtual machine, hardware running the host operating system after. So monitoring the virtual machines. So the virtualization ranging from hardware to application in 5 abstraction level. First one, instruction set architecture level, that is ISA, hardware level architecture, that is HAL, operating system level, library user level, then and finally application level. Instruction set architecture level. So instruction set architecture level, that is ISA, virtualization can work through ISA emulation. This is used to run many legacy codes written for a different hardware configuration. These codes run on any virtual machine using the ISA. With this binary code that originally needed some additional layers to run is now capable of running on the x86 machine. It can also be tweaked to run on the x64 machine. With the ISA, that is instruction set architecture, it is possible to make the virtual machine hardware agnostic. For the basic emulation, an interpreter is needed. which interpreter the source code and then convert it into a hardware format that can be read. This then allows processing. This is one of the 5 implementation level of virtualization in cloud computing. So later, next video, we will discuss about the levels of virtualization. Thank you.